So this video is going to talk about how to use ratios to solve these problems. So for a ratio, I'm going to say from the slope of the line, 2.6 grams is 1 milliliter. Or again, I'm going to write it 2.6 grams over 1 milliliter. So using that ratio, I'm going to predict the mass when the volume is 27 milliliters. So I'm going to do 2.6 grams is 1 milliliter equals. Big idea is with this equal sign, the top and bottom units have to match. So my top and bottom units have to match. The problem says 27 milliliters. So I put the 27 with milliliters, x with grams. I cross multiply 2.6 times 27 times 27 equals x times 1, which is just x. And when I solve that, I'm going to get 70 or 70.2 grams for that one. So that's how I solve it using ratios. For the next one, start with the exact same ratio, 2.6 grams is 1 milliliter. Do my top and bottom equal sign. Top and bottom units have to match. And I put 250 milliliters with the milliliters on the bottom. X for the grams. I'm going to cross multiply. I'm going to have 2.6 times 250, which is 650 about, equals x times 1. Again, the 1 doesn't matter, so I'm going to have 650 grams. For the third one on here, I'm going to again start with my ratio, 2.6 grams, 1 milliliter, equals, and I'm going to do grams on top, milliliters on the bottom, and that 50 goes with grams, and x for milliliters. So I'm going to have 50 times 1 is 50 equals 2.6x. To solve for x, I divide both sides by 2.6, and I get x as 19.2 milliliters. So again, I cross multiply. So 50 times 1 is 50. 2.6 times x is 2.6x. Solve for x, and I get my 50 divided by 2.6 or 19.2 milliliters. For the next one, it says using the ratio, predict the volume when the mass is 5 grams. So I'm going to take 2.6 grams is 1 milliliter. Take 5 grams to x. So I cross multiply, and I get 5 equals 2.6x. Okay, 5 times 1 is 5. 2.6 times x is 2.6x. I divide both sides by 2.6, and I get 1.9 milliliters. So that's how I go about solving these problems. Next, it says, cite evidence from the table and provide reasoning as to why your answer for the above question is a reasonable answer. And so what I'm going to do is I'm going to look and say for 5 grams from the table, 5 grams is between, and when I look at the table, 2.7 grams and 5.4 grams. Okay. And so I want to see my answer. What correlates with the 2.7 grams? It was 1.0 milliliter. And on the table, 5.4 grams was 2.2 milliliters. And so I'm going to look, does 1.9 for my answer above match with is it 1.9 between 1 and 2.2? The answer is yes. So I can say, so 1.9 milliliters is between 1.0 milliliters and 2.2 milliliters. And in fact, it is closer to 2.2 milliliters. So my answer makes sense. So that's how I can, again, use that reasoning using that table to support it. Finally, it says, what do I notice about the top and bottom units for the ratio? And they are the same. They are the same. Because what does an equal sign mean? An equal sign means the same. Top and bottom units are the same. So that's how I'm going to go about solving these problems using ratios.